Hey guys, time for the next video of completing the square. This one is 2x squared plus 20x minus 8. If we look at our step 1 says if a does not equal 1, we need to divide both sides of the equation by a. So if I zoom in here, I need to begin by dividing both sides of this equation by 2. Divide by 2, divide by 2, I'd be left with x squared plus 10x minus 4 equals 0. So step 1 is done. Step 2 says rewrite the equation so that the constant term is alone on one side of the equal sign. So I need to get my constant by itself. So right here is my constant. I need to get that by itself. So I'm going to add 4. They're going to cancel out. Be left with x squared plus 10x. I'm going to leave a space there. Equals a positive 4. So step 2 is now done as well. Step 3 says square half the coefficient of x and then add this square to both sides of the equation. So if I zoom in again, my x term is 10. So 1/2 of x would equal 5, and 5 squared equals 25. So I'm going to add 25 to both sides of my equation. I do this in order to create a perfect square trinomial. So I am now done with step 3 of my problem. We'll move that over out of the way just a little bit. There we go. Now I can factor my trinomial on the left-hand side. This will factor down to just simply x plus 5 squared. Remember, I'm factoring that because I'm looking for two numbers that multiply to be 25 and add to be 10 at the same time. Or don't forget, wherever half of my x term is, that will be what goes inside my binomial. And that is going to be equal to 29. And now I need to take the square root of both sides in order to get rid of my exponent. Those would cancel out. So I'd be left with x plus 5 equals plus or minus the square root of 29. So now I need to solve this problem for both ways. I need to solve this problem when x plus 5 equals a positive square root of 29, and when x plus 5 equals a negative square root of 29. Be careful that that negative sign goes on the outside of your square root symbol. If you put it on the inside of your square root symbol, that would be an imaginary number, and we're not to that point yet. To solve the left-hand side, I would, and I guess I'm going to zoom out real quick. I skipped a few steps. I have now also factored, and I'm currently using the square root property to solve these. I would subtract 5, my 5's cancel out. That would leave me with x equals the square root of 29 minus 5. And if you use a calculator, that would give you approximately x equals 0 and 39 hundredths. And if you go on the right-hand side, I would subtract 5, those would cancel out. I'd be left with x equals negative square root sign 29 minus 5, which would be, if I type that into my calculator, approximately x equals a negative 10 and 39 hundredths. So there is example